I will start with this example. But before starting this example, I would like to remind you for something. Guys, you have to remember all the time, if we have inclined surface with angle theta, and you have an object, and this object has weight, all the time, this weight in a vertical direction to down. Probably you have another force applied to this box. If you have any other forces, please, all forces must be broken in direction parallel to the inclined surface and perpendicular to the inclined surface. All forces, whatever you have, all forces must be broken, must be resolved in direction parallel to the inclined surface and perpendicular. This angle theta for the inclined surface equal to this angle between weight and the normal direction for this inclined surface. And this angle theta equal to this angle theta by Z shape. So I can say I will have a component in this direction W sine theta and another W cosine theta in this direction. For this F, I will have a force F cosine theta in this direction and F sine theta in this direction. Any question for this point? If you have any inclined surface, please, all forces must be broken in direction parallel to the inclined surface and perpendicular to this inclined surface. Just a reminder also, the friction force equal mu time N. What is the meaning of N? All forces perpendicular to the contact surface. I think in this case, they will be W cosine theta and F sine theta. Any questions so far for this point? If you have any question, let me know. I have a question, and I need someone to tell me. Okay, the magnitude of the friction force equal mu time N. I can figure it out. Anybody can tell me what is the direction? For this case, for this box, we have a box under the effect of these forces. Can you tell me what is the direction of the friction force? I need to listen to your thought. Can you tell me what is the direction of the friction force? Before answering, I told you before, friction force opposite to the direction of movement. That's right. Upward. Why? You should answer this question like this. It's not upward. It's not downward. You should answer this question like this. Hey, I need to figure out what is the value of this force. Value 1. And what is the value of this force? Value 2. And you need to judge between both of them. If value 1 greater than value 2, this box will move to down and the friction will be to up or to upward direction. This is the first case, probably can be happened. If this force greater than this force, the movement of this box will be to down, there is a friction to be upward. Sometimes this will not happen. Sometimes this force value 2 greater than value 1. So this force will push this box to upward. That means the friction will be to this direction. You got it? You got it? That makes sense? Okay, let me explain it in more details using this example. We have a box or block with 300 pound weight. So the weight of this block will be vertically to down, 300 pound. And we have a force, 100 pound, acting on this block to upward. In this direction, you are lucky. In this direction. Before doing anything, do you have any other forces? No, we have only two. The weight of the block and the applied force, which is 100. Why you are lucky? Because I would like to resolve, I would like to break each force to two dimensions or two directions. Parallel to the inclined surface and perpendicular to the inclined surface. 100 pound, I don't need to do anything because 100 pound already in the direction which is parallel to the inclined surface. I am good with 100, but I'm still not good with 300, which is the weight. I'm gonna assume this angle theta, which equal to this angle theta. So this weight will be broken in this direction, 300 cosine, I'm sorry, sine theta and 300 cosine theta. By the way, this angle theta will be inside a right angle triangle 4, 3, 5. So I can figure out the value of sine theta equal 3/5. The value of cosine theta equal 4/5. So I can remove sine theta and put 3/5. This value will be, I think, 180. Yes, 180. And this value will be 240, I think. Pound. Any question? Any question? We have the coefficient of friction, mu is given. And the problem asked to determine the value and the direction of the friction force. Okay, friction force equal mu time n. Mu is given 0.25. What is the value of n? All forces perpendicular to the inclined surface. What forces do you have perpendicular? 240. That's all. Your value will be 60 pounds. Can you tell me what is the direction of this friction force? What is the direction? To determine the direction of friction force, you have to determine the direction of movement. Let's see. The effect of weight with 180 pushing down. And we have applied force 100 pound pushing up. Which one is greater than the other one? I believe 180 is greater than 100. So this block will be moved to down. That means the friction will be upward like this. So the direction of the friction will be like this, upward. How much? 60 pound. That makes sense for you guys? That makes sense? Value of the friction force, piece of cake, just mu times n. To determine the direction of this friction force, we need to figure out which direction this block will be moved to down, then the friction direction to up, and vice versa. Okay, I have another question. Determine whether the block will be slide or not. What do you think? Sliding will happen, yes or no? Okay, let's go back to the forces. We have two forces going up, 100 and the friction force 60. So the total is 160 going up. However, we have another force due to the effect of the weight coming down 180. So what do you think? Which one will overcome the other? I believe 180 will overcome this force 100 and this friction force 60, and this block will slide to down. That makes sense? I think, yes. So the first step, when you break each force to two components, one parallel to this inclined surface and one perpendicular, is very important. Is very important. Please be careful. Once you resolve it, each force to two components, you can decide which one is greater. So you can decide what is the direction of the movement. You can decide what is the direction of friction. Okay, one more example. One more example. But before going to the next example, do you have any question so far? Do you have any questions so far? Okay. Let's see what's going on in this one. We have inclined surface with angle 20. That's fine. Okay. Determine the magnitude and the direction of the friction force. Okay. Acting on the 1000 Newton block. This block has a weight W equal 1000 Newton. This weight vertically to down. If B, we have a force P which is horizontal. This P is given 500 Newton. And this P is in a horizontal direction. Okay, before doing anything or thinking what's going on in this problem, we need to do a step. The first step, we need to resolve or break these forces to two components. One parallel to the direction of the inclined surface and one perpendicular to the inclined surface. This is the first step. Guys, this angle theta equal this angle theta for the weight. This angle theta equal this angle theta by Z shape. So I can say for weight, we have component here W sine theta. Theta is given 20. W is given 1000. This value will be 342 Newton. And we have another component here for the weight will be 1000 cosine theta. So 1000 times cosine 20 will be 939.7. This force 500 can be broken like this, 500 cosine 20, and like this 500 sine 20. 500 cosine 20 will be 469.8. 500 times sine 20 equal 171. Do you have any other forces given? No, we have only weight 1000 and applied force 500. Okay, let's start. To figure out the value of the friction force, it's a piece of cake. Mu times n. Mu is given 0.2. What are the forces n which are perpendicular to this surface of contact? All forces, please. Perpendicular to this surface, we have 939.7 and we have 171. This one and this one. So I can figure out the value of the friction force. It will be 222.14 Newton. This is the magnitude of the friction force. Can you tell me what is the direction of this friction force? Do you think this friction force going to this direction or going to this direction? Let's start. What do you think? Okay. The effect of weight is 342 coming down. But the effect of the applied force of 500 is 469 point something, 0.8, I think, or 0.7, going up. So which one will overcome the other one? I believe this force will overcome. So this force will push this block to be moved upward. So I believe the friction will be to down. So the direction of the friction will be downward.